Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Kazri Khalidan, and today I will be talking about rice husk ash as sustainable material. So the research question of this article is the using of rice husk ash as fine aggregate sustainable material for strength enhancement of conventional and self-compacting concrete. And the objective is to study the effect of partial replacement of fine aggregate with rice husk ash on mechanical properties of conventional and self-compacting concrete. So for the procedure is firstly, the fine aggregate will be replaced with rice husk ash in conventional concrete with 6 different percentage by weight such as 0, 10, 20, 30, 40 and 50%, having water cement ratio of 0.375 with variation of superplasticity dose, whereas in self-compacting, the replacement of fine aggregate by rice husk ash is 0, 10, 20, 30 and 40%. Next, the design mix for conventional concrete is targeted for M30 grade concrete, and to determine the workability of the fresh concrete of self-compacting concrete, the slum test has been conducted using the slum mold. The value must satisfy the IFNAC 2005 guideline up to 30% replacement of fine aggregate with rice husk ash, while 40% replacement will not satisfy the guideline. Then, the compressive strength and flat zero strength has been tested using compression machine and flat zero test machine and will be determined at 7, 28 and 90 days. Lastly, the test result of compressive strength and flat zero strength shows that up to 30% replacement of fine aggregate with rice husk ash enhances the strength in conventional concrete, whereas the strength enhancement in self-compacting concrete is up to 20% replacement.
Assalamualaikum to society. My name is Muhammad Amirul and today I would like to present about result conclusion discussion. For fresh concrete, the ability of fresh CC is measured by slam test and we get it in table 6. And for compression strength, the maximum compression strength for 7, 28 and 90 days is that you mentioned. And the compression strength of comparison for 10% to 40% is 10% replacement, which is this one. And for 20%, 22.22, 16.13 and 30.87, and for 30%, 13.79, 6.41 and 4.58, and the last one 40% is 7.41, 2.65 and 4.85. The pleasure strength, the same thing. First we observe the pleasure strength and we get this one, and for 10% 23, 11.95 and also 12.17, 20% 25.14, 11.24 and also 12.70, and for the 30% is 11.42, 2.69 and 5.77. That's why which is 40%, 40.12%, 2.02% and also 1.75%. It's all for 7, 28 and 90 days. For the conclusion, it is observed from the experimental result of slum test, slum value 30 to 50 millimeter, and 30% replacement is satisfied, which the guideline, and 40% replacement of fine aggregate with area is not suitable for SEC. Each of carry increase, compressive, flexible strength, and split strength of SEC increases. The utilization of RHA as replacement material of cement in sense of the problem of its disposal, thus keeping the environment free from pollution. For discussion, Rahas is a good sustainable material to replace the fine aggregate. Rahas utilization as supplementary cementitious by reducing carbon dioxide. Rahas material can be put to effective use in the prison without compromising the availability for use by later generation, and that give a benefit and represents well-being of human general environment. Rice has also a natural evidence and ease of extraction with respect to amount of energy used and ease of recycling. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nazmi bin Muhammad Nafandi. Now I'm going to present glass waste replacing fine aggregate. Concrete is the most common use of construction material in a building. Because of the continuous use of very high amount of materials to produce concrete, it is vital to find alternative resources to replace the limited resources we have. Thus, the researchers generally propose the use of recycled waste glass as fine aggregate. In addition to this, using the recycled waste glass will decrease the overall amount of solid waste, which in turn will positively affect the environment. Procedure for mixture proportioning. Two types of concrete were prepared. Firstly, for plain mix, consisted of sand, gravel, cement, and water, resulted with water concrete ratio of 0.53. The other concretes were made of waste glass aggregate of 10%, 15%, and 20% as a partial replacement of sand with the same amount of other material. The concrete mixes were cured for 3, 7, 14, and 28 days. Next, for procedure for preparation of specimen. Firstly, the mold were coated with mineral oil. Concrete casting was accomplished in 3 layers of 50 mm each. Each layer was compacted by using vibrating table for 1 to 1.5 minutes. The molds were dried for 24 hours and removed from the mold and immediately submerged into water for testing. Okay, testing of the specimen. Firstly, during fresh concrete, slump tests were used and fulfilled according to the British standard to determine the workability. Next, compression strength. Concrete cubes were prepared according to the British standard. The Foley machine was used for compression testing. The cubes were tested immediately after being taken from the water storage. The average of compression strength of four cubes was recorded. Flexural and toughness strength. Prism was prepared according to American Society for Testing and Material Test method. A 10 kN proving ring and 0.1 mm dial gauge precision was used. The flexural testing was carried out according to the American Society for Testing and Material Test method. The toughness indices were implemented according to American Society for Testing and Material. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaidi bin Muhammad Rani. Today I will present to you the waste glass replacing in fine aggregate. Okay, so today I will present about result which is consists of compression test, flexural test and slump test. As you can see here, for compressive strength test, at the 20% of waste glass, at the 28 days, it increased about 4.23 from the 4.23% from the controlling mix, as you can see here. So controlling mixture are only using fine aggregate and not using any percentage of waste glass. So the next one is flexural test. Flexural tests are presented same pattern which is 3rd, 7, 14 and 28 days. As you can see here at the 20% of waste glass, it is also increased from the plain mix. And the last one is slump test. However, for slump test, with increment of percentage in waste glass, it will decrease the slump, which means it might be the concrete mix are not workable. So in discussion, compressive strength test, for according to the result, as you can see here, highest result in 28 days is 45.9%, 45.9 megapascal by mixing 20% of waste glass of fine aggregate. The compressive strength relatively increased about 4.23% from the controlling mix. But however, as you can see at the 14 days, it decreased from the others. This might be occur due to less adhesive strength between surface of waste glass aggregate and cement paste. Next one is flexural strength test. As you can see, flexural strength test presented in result, as we can see that the 28 days flexural strength will increase above the plain mix by 3.57%, 6.96% and 11.20% with increment of 10%, 15% and 20% of waste glass respectively, as you can see here. This shows that pozzolanic reaction had taken place during this period of time. For slump test, although the increment of waste glass will causing of the decrease in slump, the mix are still considered as workable. So, as conclusion, the slump of waste glass concrete specimen decreased with increases of waste glass content. This occurred due to waste glass grain shapes. Despite this decrement, the mixture are still considered as workable. The usage of glass definitely will increase the maximum compressive strength from the plain mix about 4.23%. Same goes with flexural strength, where result shows that the waste glass can improve the flexural strength of the mixture. Using waste glass as fine aggregate might come up with promising outcome. Lastly, the objective had been achieved as to reduce the glass waste in this world. But I wanted to try glass waste in coarse aggregate, since if we are using glass waste in fine aggregate, it took longer time to crush the glass into very fine aggregate. So if we want to save the time, try to mix it with the coarse aggregate, replacing the coarse aggregate of the concrete mixture. So overall, there is nothing with this journal. The results are quite convincing, and that's all from me.